So what is radioactive decay? Well, we know that radiation coming off of some radioactive substance is energy that's being released from the nucleus of that object or that radioactive substance, either in the form of alpha particles, beta particles, or gamma rays. Gamma rays with a G. The interesting thing about alpha particles and beta particles is that these are made of actually mass that's coming out of the nucleus. An alpha particle is 2 protons and 2 neutrons, and a beta particle is an electron that came from a neutron turning into a proton. I'm going to abbreviate proton. So if we have that going on, if we have 2 protons and 2 neutrons leaving the nucleus, or if we have an electron making a neutron go into a proton, that means we're changing the number of protons. Both of these change the number of protons in that atom. If we change the number of protons, we are changing the actual atom. It's turning into some new atom. That process is called transmutation. That's a new word for us. Transmutation means changing the number of protons through radiation to turn into some new atom. Every time that happens, we change the number of protons and we'll get a new atom, and we're going to be becoming slowly less and less radioactive until eventually, with the case of uranium, uranium is going to turn into lead with an atomic mass of 207, which is not radioactive. It's going to get there through a long pathway. It's going to be a bunch of different atoms along the way. But the key so the things to know with radioactive decay is the uranium is not going away. It's just that parts of it are shooting out in either alpha particles or beta particles, and the atom is turning into new atoms. So what about gamma radiation? Well, gamma radiation is a photon. It's a high energy light particle, a photon, that has no charge and basically no mass, so it's not changing the nucleus of the atom that it comes out of. It is releasing energy, and so that nucleus is going to be a little bit more stable, but it's not going to change what that atom is. So it's not necessarily involved as much in the radioactive decay that we are studying. Let's take a quick look at an example of radioactive decay. We have the element thorium, which has 90 protons inside its nucleus, and we'll look at the isotope of thorium, which has 231 total protons and neutrons all put together. Remember, there's different isotopes of many atoms, which means the same number of protons but different numbers of neutrons. We're going to look at thorium-231 though. Thorium-231 is radioactive, and it shoots out a beta particle, which is essentially an electron, or you could draw it as the Greek script for beta, which has a negative charge. When we shoot out this electron, it's coming out of the nucleus. Now you're asking, what is the electron doing in the nucleus? Well, it's a beta particle, so it's a neutron that releases that electron, and the neutron then changes into a proton. If we go from a neutron into a proton, our new element now has 91 protons, which are going to go down here in the bottom. And do we lose any mass? Not really. The electron doesn't really weigh anything, so we're still going to have 231 protons and neutrons inside the nucleus. The key is one of the neutrons switched teams and it became a proton. So we add a proton, we get 91. Then when we look over at the periodic table, we see that an atom with 91 protons is protactinium, which has an abbreviation P A. So for us, our thorium gained a proton. The number of protons and neutrons altogether didn't change, but the number of protons changed, and it became protactinium. As we can see, radioactive decay is releasing radiation from the nucleus, and when we release radiation from the nucleus, in most cases we change what that nucleus is made of, and that's going to change our element. And that's going to be happening slowly over time for all radioactive elements.